Okay, after the remark, let us come back to discussion of decision trees. Okay, so a decision tree is a class of methods. Okay, all of them are actually segments the predictor space, which is the X, okay, into number of simple regions, okay, based on the Y in some way. Okay, and I already mentioned that in R, okay, we have the R part packages and trees, which actually supports construction of decision tree. They are not the only packages for that. We have others such as Party, C50, etc. Okay, in Python, it's a bit standardized. It provides just decision tree, okay, for classification problem, okay, classifier, and regressor for regression problems. Okay, as I mentioned in my remark, it's difficult to find simple examples which illustrates things. Okay, but for decision tree, it's sort of possible. Okay, so I'll try to use the following simple example, which comes from discrete maths. Okay, so I hope all of you still remember the truth table, okay, where you are asked to memorize, okay, for the definition of implication, okay, to form a compound statement P to Q, or P implies Q, where both P and Q are propositions. So because they are propositions, so we can evaluate them to be either true or false. Okay, therefore, we have such a truth table. So how do we encode this truth table in computer programming language? Okay, I'll illustrate with R, okay, because we've been using R throughout our practical class, right? Okay, let us take a look at how R actually defines a function. So the way R defines a function is by using the keyword, okay, called function, which you can see over here. And this is the name of the function imply. Okay, it takes two parameters, P and Q. Okay, inside the bracket are various expressions. Okay, so you can find that the whole programming based on the if-else statement is more or less following the table. Okay, just look at the order: true, 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 false, false, true, and finally false, false. Okay, it's the same here: true, 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 false, false, true, and false, false. Okay, and these are the return values. Okay, so we can actually see that just based on the table, it's possible to construct a program to map the cases and return the values based on the matching conditions. Okay, in Python, the definition of a function is slightly different. In Python, it uses def for defining a function. Okay, a function of name imply, which takes two variables, P and Q. Okay, the if else is more or less the same, except for in Python it's possible to construct else if, okay, with an special keyword, okay, elif. Okay, what one needs to know about Python is the definition of Python is a bit different from R. Okay, so we need to return the values. Okay, so after matching, right, we assign the values to R. Okay, maybe I should call it y, okay, but never mind. Okay. Anyway, once it's assigned, right, okay, so finally we can return the value. Okay, now let us look at C++. Many of you have learned C, C++, so C++, we need, when we define a function, okay, we, apart from giving a name, we need to give it the type. Okay, so it takes in two Boolean values, P and Q. So Boolean actually means either true or false. Okay, so the construction is more or less the same as Python or R. It's just the syntax is slightly more verbose, where you need to type more things. Okay, so yeah, it's more or less the same. And all these are in programming languages, but if we draw it out, okay, we can draw it out using binary decision tree. Okay, the way to draw it out is quite simple. Just look at the first column. Okay, first column is P is either true or false. So we try to compare P to true. If P is true, okay, then means yes, right? Okay, because this. Okay, if then we can check about Q. If Q is also true, okay, then it's a yes, so it implies that the final output should be true. Okay, what if P is true but Q is false? So if that's the case, then it's a no, because when Q is false, false equals to true is not true, so it's a no. So the output is a false. Okay, I think now we can look at the third row, okay, where P is false. So when P is false, false equals to true, of course, is a no, right? Okay, so if it's a no, then we would need to try to check what is Q. Okay, when Q is true, okay, we know it's a yes, so output should be true. But even if Q is false, if false equals to true is a no, okay, so but according to the table is still true. Okay, so let's look at this blue note. Despite the fact that okay, we can add in this condition checking, but the output is always true. And if you recall, in the previous video, I mentioned about the concept of purity. There are measures of purity, okay, in section 7.2. Okay, so this more or less means that this splitting here is actually pure. And pure means it more or less doesn't give us information. Okay, so that's why this node is more or less useless. We can just replace this whole node with true. Okay, that's why we have the next slide. Okay, so whenever P is a false, okay, the output would be true. Okay, so this thing here more or less still remains, but programming wise, okay, let us look at the next slide. Okay, we find that, okay, if, okay, again imply, right, a function which takes in P and Q. So when P is true, okay, what happens is instead of checking Q again, we just look at this thing. When Q is true, output is true. When Q is false, output is false. So what does that mean? So we can just return Q, right? Okay, that's why we see a Q here. Okay. On the other hand, if P is not true, okay, indicating what? Then it's false. False, okay, the return value according to the previous simplified decision tree okay, is actually true. So what does this example mean in general? Okay, what it means in general is we can think of it as very special case of a general situation where we have a gigantic database. Okay, the database of any company will consist of information related to the operations of the companies, the employees of the companies, the customers of the companies. Okay, so all these relation, okay, are stored in database. Okay, in traditional or modern form, where some of them are stored in so-called cloud. Okay, which is internet server. Okay, which service supplied by giant companies like Google, Microsoft, and so on and so forth. Okay, then normally what we will be doing is we would want to extract information from the database. Okay, in order to do that, we need to perform a query. So something like asking the database to supply the data. So once we get the data, we want it to put it into tabular form, which are familiar to us. Okay, so that's why we have a data table. Okay, so based on this data table, we want to construct a decision tree, because a lot of times in any operation, we want to get the features right, okay, to make decisions. Okay, so that's the main reason we decision tree is popular. Okay, and for the once we have the decision tree, then we can start to construct computer statements and then run it and process our data. Okay, are things always that simple? It's not always that simple. The first thing one has to remember why our example are considered oversimplified is because in the table here, you can find that our P and Q are actually just binary values. In general, it can have multiple values. Okay, it can be numeric. So it's never so simple. And there is also another case which is something we need to be aware of. Okay, so we can have numeric values. We can have okay, this is still two values, but if we add in more, okay, then we might have designed a range where tall, very tall, okay, and so on and so forth. Okay, so CGPA and numeric values and lights. It's in this case it's binary value. In general, of course, you know it's not binary. Okay, so this is hopefully a bit more realistic data. Okay, which is trying to analyze the preferences of some probably students, okay, based on their height, okay, and also their CGPA, whether they enjoy or like nasi lemak or mixed rice. Okay, but what is important for all of you to observe is, okay, you can find that the first row and the fifth row, okay, both of them have exactly the same value, but they have different preferences. And okay, it's a similar case for medium 3.1. Okay, two person, one prefers mixed rice, the other prefers nasi lemak. So it's impossible to write a computer program to actually return okay, return mixed rice and nasi lemak is It looks a bit funny. Okay, so when you want to actually construct a decision tree, in this case, then probability again arises. So meaning when you encounter this situation, there are 50% chance that he or she may prefer mixed rice or nasi lemak. Okay, so we'll be using R to actually check what is the return value of the computer program. So as all of you are already familiar throughout the practical classes, okay, we can construct a data frame for the table given in the previous slide. Okay, and then I already mentioned about the three packages, so we just call it assuming you have installed in your R. Okay, otherwise you need to use install packages. Okay, tree to select from any site, okay, and then install on your R software. After that, as how we will be constructing the model all the times, just choose the right name, okay, for decision tree. Okay, it's called a tree, and this part, okay, lights corresponds to the output, okay, and dot will correspond to the rest, which is the height, and CGPA would be the rest. Okay, and it forms a formula. So lights depends on the rest. Okay, so this is just a formula. We need to train a model from data, so we need to give it the data. Okay, so that's why we pass in the data frame. Okay, so once the algorithm gone through the formula and the data, it would return a model. Okay, and we can just print it out or print a summary of the model to see what's going on with the model. Okay, so what's output? The output is something like this. Okay, so let us interpret it. Okay, the node tells us how many nodes we have. We only have one node, and it's split just at the root. Okay, there are 5, n equals to 5, right? So there are 5 rows. Okay, deviance is some statistical value which I have not learned. Okay, so I have no idea what it is. Okay, y value is basically the response value. Okay, so mixed rice has a because it's a binary case, so it has probability of 0.6 taking mixed rice and 0.4 not mixed rice. Okay, so it indicates its terminal node, meaning okay, then this is the leaf, right? So basically it's just a binary split. Okay, so these are the probability, and what does this tells us? It tells us that decision tree algorithms okay, can't tell us everything. Okay, if the data itself does not contain useful information. Okay, so because we have conflicting outputs, so basically the algorithm discovered that okay, the features of the height and CGPA doesn't tell us anything about the output. Okay, so let us proceed to summarize the packages related to the R programming. Okay, tree library. Okay, you already seen it just now. So the key when using this library is to know that the function tree from this library, okay, can take in training data, label training data with the features xi and the output, okay, to be both nominal and numeric. Okay, so it can handle a mix of categorical data and numeric data nicely. So tree is actually a very powerful model. Okay, so the general formula is, of course, y depends on x1 until xp, right? But depending on the algorithm, p may not be very large, otherwise the generated tree may be extremely large when you have too many features, okay, and also too many data. So the prediction, like all the examples you have encountered in the previous practical classes, okay, is to just predict from the model which we train, okay, and then giving it a new feature data, okay, and then we can get the response. So basically a prediction of the response directly returns the class. Okay, so basically it just tells you what is the class, or in the regression case what is the value. Okay, you have seen print just now. If you actually have a tree with more than one node, okay, just now it's one node, so there's no plot there. Okay, it's just one node, so nothing to draw. Okay, in general we would have a plot, okay, because it will have many nodes, okay, and then we can use this to actually draw the tree out. Okay, another more popular and more powerful library is the R partition library, rpart. So the key is the same, so all these y and x could be numeric, and it can also be categorical. Okay, so apart from the difference in name, okay, the whole thing is more or less the same. The parameters is actually different in the two for these two algorithm, okay, rpart and tree, okay, but calling it okay, all of them are more or less the same. Okay, we'll stop here and continue with section 7.3 hopefully in the near future. Okay, thank you.